Alright, so today is day 2 of 5.5. So a couple of things that I want to accomplish today. I do have stuff to hand back to you. And I want to go over some homework problems. Somebody just asked about going over some homework problems. We'll go over some of those. And then I want to give you some insights into today's homework. So right now, the single sheet of homework should be away for right now because it's focused in on the task at hand so that we're actually paying attention and that we understand what we're doing. So let's do homework packet first. So are there any questions from, we'll go page by page here. Are there any questions from the first page of the 5.5 homework, numbers 1 through 9? Number 9 on this one? Okay. So number 9 here says the first thing that we would do, we got to get it in standard form. It's in slope-intercept form. We got to get x and y first on the same side. So right away, I would add 1/6 x. Okay. Now that's going to give me that, okay, which on a test or a quiz I would accept. But last night on the homework we said let's go to true standard form and let's get rid of those fractions. So if I'm looking at the denominators, 6 and 3, okay, the nice thing is that 3 evenly goes into 6, right? Goes in there twice. Okay? So that means that I can multiply everything, every term, just by 6. And it should clear both fractions all at once. Okay? Okay? So 1 times 6 is 6. Divided by 6 is 1. So that leaves me with x. 6 times 1 is 6. So that gives me 6y. Okay? 2 times 6 is 12. Divided by 3 is 4. So then that would equal 4. And that one would be the answer. The top one?
No.
The top one?
Yeah.
Mm-hmm. Okay. On a test or a quiz, yes. We asked you last night to do it without any fractions or decimals. Yes, and like tomorrow on a quiz, yes, I would accept it. But today on the homework, no. Okay. Number 10. Any questions on number 10? Yeah? Questions on number 10? All right, let's do number 10 together. Okay? On a final creative writing course, Ben was required to write a combination of at least 10 poems and or paragraphs. Ben knew that each poem would take him 30 minutes to write, while a paragraph would only take 10 minutes. Ben was given 2 hours to complete the exam. So the first one, it says, write an inequality to model each constraint. So I believe the constraints were time and items. Okay, so let's deal with time first. What do we want to use for our variables? X and Y. X is going to be poems. Okay, so we should write that down here that X is poems. That means that Y then is paragraphs. Okay. So time, how long does it take to write a poem? 30 minutes, so in my equation that's going to be 30x. How long does it take to write a paragraph? 10 minutes. So in my 10y, your style is, you can grab it, it's fine. No, it's not the first time that something's fallen on the floor. What am I going to do with 30x and 10y? Add them together, okay? So that's the amount of time that it's going to take it, correct? But how much total time does he have? He has 2 hours, which is 120 minutes. So he has to do that in less than or equal to 120 minutes. Because we were dealing with minutes on the first one. Okay. Then we have an items. How many poems is he going to write? No, I'm talking about how many poems is he going to write? No, how many poems is he going to write?
We don't know.
How many poems? We do know.
10 y.
No, that's
30.
time. How many poems is he going to write? Not y. X. He's going to write X poems, right? How many paragraphs is he going to write? Y. What am I going to do with X and Y? Add them together. And all told, that has to be greater than or equal to, because it said at least, right? Greater than or equal to 10. Okay. Graph it now, it said. Okay. Okay, yeah, perfect. We can go by one. Okay. So my time graph was, let me just get a rewrite it here. Items graph. Do I need negative values on my x-axis or my y-axis? Nope. Okay. So we can go there. So we said X's was poems, right? And Y was paragraphs. I think we can go by ones, if I'm not mistaken. Okay. So items to graph. Which one you want to do first? Left one or right one? Right one first? Okay. So how you want to graph it? You want to graph it intercepts or you want to graph it slope intercept? Slope intercept form? Okay. So then I would be thinking about this as x plus y equals 10. So then I would subtract x and I'd get negative x plus 10 is equal to y. So that's going to be a positive 10. 2, 4, 6, 8, 10. So that would be here. And a slope of negative 1. Gets me right like that. Yes? Solid line or dashed line? Solid line. Yep, solid line. Okay. Make sure you draw in your axes too, so you don't know where. Solid line there. Test point. I don't know,
2, 2.
2 comma 2. So if I plug in 2 comma 2, then I get 2 plus 2 is greater than or equal to 10. Is 4 greater than or equal to 10? No, that's false. So that means I should shade on the other side of the line. So let's pick a second test point. Let's pick 10 comma 10. Ten plus 10 is greater than or equal to 10. 20 greater than or equal to 10. That's true. So yes, I am shading over there. Let's do the other one via intercept method. So if I have the x-intercept, that would be where y is 0. So that would be 30x equals 120. So x would equal 4. The y-intercept would be where x is 0. So that would be at 12. Yep. We can test the point 2 comma 2 again. $30 times 2 is 60. 10 times 2 is 20. 60 plus 20 is 80. And 80 is less than or equal to 120. So we would shade in there. Okay? And that's all for number 10. Okay. Number 11 is very much similar to that one, just with a different scenario. Any other questions on 10? Okay. 12 through 17. Questions there? None? What, 14? The nice part about number 14 is they're both solved for y already, so I don't have to worry about that, about solving one of them for the other. So I can put this in place of y right there. 6x minus 23 equals negative 4x plus 57. Let's add 4x to both sides. That's going to give me 10x minus 23 equals 57. Let's add 23 both sides. That gives me 10x equals 80. Let's divide both sides by 10. That gives us x equals 8. I'm going to plug it into the left one. 6 times 8 is 48. (48) minus 23 is 25. (48) minus 23 is 25. Yep. And negative 32 plus 57 is also 25. That works out. So my answer here is 8, comma 25. Okay. So if we're on the practice sheet, so now the extra sheet that you picked up when you came in to class today, okay, let's do some examples here. The first 4 at the top of the page, let's do a couple of examples here. Okay? So we need a little bit of refresher on our exponent rules because we haven't really done them in a while. So we're going to do them again now and then keep coming back to them because we're going to need them as we're going along. Okay? Exponents are really just counting. Okay? You're just counting. So this is telling me that I have here, this is telling me that I have 3 x's. This one here is telling me that I have 4 x's. So together, how many x's do I have? 7 x's. Okay? So this answer here would be 2 times x to the 7th power. Okay? So when we have the same base, we just add the exponents on them. If there is no exponent, but there's a variable, we assume that that exponent then is 1. There's only one of those. Okay? With the numbers out in front, those what we call coefficients, we're just going to take those and we're going to multiply them. So what is 3 times negative 4? Negative 12. In the first one, how many x's do I have? On the left part, how many x's do I have? 4. On the right part, how many x's do I have? 5. So all told, I've got 9 x's. So that would be x to the 9th power. On the y's, how many y's do I have in the first one? Negative 2. How many do I have in the second one? 2. Negative 2 plus 2 is 0. Do I have to write it? No, because I've got 0 y's, so it's just gone. Okay? So then negative 12x to the 9th is my answer. Okay? When you're taking something to a power, like 3m squared, then that really is 3m squared times 3m squared times 3m squared times 3m squared. Here, that many times. Okay? Which would then be 3 times 3 times 3 times 3, which is 81. Got 2 m's, then I got 2 more m's, then I got 2 more m's, Then I got 2 more m's. So all told, how many m's do I have? 2 plus 2 plus 2 plus 2, 8. I got 8 m's. Now the shortcut of that is you could take this power that's out here and you can apply it to the 3. So that would be 3 to the 4th power, which you could do in your head or do on a calculator. 3 to the 4th power is 81. Because you got to take 3 and multiply it 4 times. 3 times 3 is 9, times 3 is 27, times 3 is 81. Or 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. Okay? Then this 4 also has to go into the m squared. So this is m squared to the 4th power. And when we have a power to a power, we multiply. So 2 times 4 gets me my 8 m's that I have down here. With me? Yeah. When you have it in fraction form, you can take it and you can break it up into all of the parts. So this would be like 3 over 27 times m to the 4th over m cubed times 1 over n to the 4th times p cubed over p. So I broke it up into numbers and letters. And then you reduce those fractions as is. 3 over 27. Is there a number that goes into 3 and into 27? 7 does not go into 3. 6 doesn't. 3? 3 is the biggest one. Yep. Okay. So 3 divided by 3 is 1. 27 divided by 3 is 9. So I'm going to have a 9 on the basement of my fraction. Now with variables, you look where there's more of it. Are there more m's on top or more m's on the bottom? On top, how many more? 1 more. So on top, I need an m. Are there more n's on the bottom or more n's on the top? On the bottom, how many more? There's 4 of them down there, so those have to stay down there. Are there more p's on top or more p's on the bottom? On top, how many more? There's 2 more on the top, so that would be p to the 2nd power on top. Okay? Let's do number 1 together because it has also, well, no, hold on. I want to get a negative exponent one. There we go. Let's do number 6 together. Okay? Okay? So number 6 says we can take this power, this 3 out here, and we can apply it to the 3, we can apply it to the x, and we can apply it to the y. So this would become 3 cubed times x to the negative 4th to the 3rd power times y squared to the 3rd power. Okay? 3 cubed is 3 times 3 times 3, right? 3 times 3 is 9 times 3 more is 27. So we got 27 here. I multiply these two exponents. Power to a power, I multiply negative 4 times positive 3. Negative 12. Do we like negative exponents?
No.
No. So this would really be x to the negative 12 power, but we don't like negative exponents, so I have to make it positive by putting it in the basement. Okay? If it's negative on top, we put it in the basement to make it positive. If it's negative in the basement, we put it on top to make it positive. Okay? Power to a power here again, I multiply. 2 times 3 is? 2 times 3 is? 6. That's positive. So that's y to the 6th power then on top. Okay? You have the rest of the time to complete that worksheet. Okay? Just as a side note, your stamp sheet does not have a spot for said worksheet on it, so we are going to stamp it at the bottom of the stamp sheet. So if you get out your stamp sheet right now, and below the grid there, if you change it to out of 32, and then put a 5.5 down there, 5.5.5, excuse me, down there,